Here we have to show that if Q0 be the set of non-zero rational numbers, then Q0 under a binary operation multiplication forms a multiplicative abelian group. So first of all, you have to know what is this abelian group. Let's say that G is a group under a binary operation star. Then what are the properties satisfied by this group? The first one is the closure property. The second one is the associativity, and then we have the existence of identity element, existence of inverse. Now we have the last one, which is called as the commutativity. If this axiom is satisfied by a group, then this group under a binary operation star is called an abelian group. Okay, so let's start. We have to show that this one forms a multiplicative abelian group. First one, we check for the closure property. For that, we take two elements from Q0, A and B. These two belong to the set of non-zero rational numbers. Then clearly, if we take their product, that product also belongs to Q0. Okay, hence closure property is satisfied. Second one, for the associativity. Here we take three elements, A, B and C from Q0. Then A into B into C is always equal to A into B into C. Hence, the associativity also is satisfied. Now we check for the existence of identity element. For this set under a multiplication binary operation, find an identity element such that A into E is equal to E is equal to E into E. Find that identity element for this one. Okay. By looking at this, since we have a multiplication and we have the set of non-zero rational numbers, then clearly one is the identity element. Why? Since we go according to this one, since, sorry, here it should be E. Okay, it should be E. Since if we multiply this identity, this one is an identity, with any element E from the set of non-zero rational numbers, that is Q0, that one is always equal to E. It is equal to 1 into E. Go according to this one. Now we see that we can find an identity element such that the product of that identity element with an element E, which is from Q0, is always equal to E itself. Hence we see that the identity element also exists. Now we check for the existence of inverse. Existence of inverse. Now, for the existence of inverse, find the inverse of an element. Let's say that the element is E and its inverse is E inverse. Find this inverse such that when you multiply E with A inverse, that one is always equal to E, which is equal to A inverse into A. If we can find this, that means there exists an inverse. Since from here we already know that the identity is 1, okay, then let A belongs to Q0. Then we can find the inverse of A such that A into A inverse is equal to E. What is E? It is equal to 1. And it is equal to A inverse into A. Why? Because for A inverse, we can write it as 1 upon A. And then we get the identity itself. So here also, the inverse of an element exists. Now, the last one is we have to check for the commutativity. Here we have to take two elements, let's say A and B, from the set of non-zero rational numbers. Then clearly under a binary operation multiplication, A into B is always equal to B into A. It is always equal to this, okay? Since we see that A into B is equal to B into A, we say that this commutativity also is satisfied by this one Q0 under a binary operation multiplication. Hence, this set Q0 forms a multiplicative abelian group. Abelian group because this one is satisfied. Okay?